4.5 billion years ago, a Mars-sized planet slammed into early Earth. The debris from that collision clumped together to form our moon, setting the precise physical conditions required for life to flourish. When you look at this image of the full moon, it appears to be a quiet, decorative rock. But that gray surface is what actually regulates the rhythm of our oceans and the stability of our planet's tilt. To understand exactly how much work it is doing, let's run a thought experiment. Imagine a massive explosion instantly vaporizes the moon into dust. Instantly, the gravitational tether holding Earth's oceans in place disappears, leaving a massive power vacuum in our orbital mechanics. Even though it sits 400 times further away, you can see in this image of our sun that its sheer mass and immense scale mean it immediately seizes control of the Earth's water. Removing a single orbital body from a balanced planetary system triggers a mathematically certain chain reaction of destruction. This diagram shows how the system operates. The moon's gravity acts as a counterweight to the sun, managing our tides in a constant, balanced tug-of-war. When we remove that opposing force, the sun's unobstructed gravity rips into the ocean, pulling the water into massive, uncontrolled mega-tsunamis. Looking at the dense infrastructure along Limbai's Marine Drive, the threat becomes immediate. Within 60 minutes of the explosion, the first wave of water reaches these buildings, submerging the coast under a massive surge. The rising sea levels submerge exposed southern landmarks. Looking at the isolated Thiruvalluvar statue and the Vivekananda Rock Memorial, you can see the water rising until they are completely buried under the surge. Gravity operates as a real-time tether. Without the precise counterpull of our nearest neighbor, our coastlines are undefended against the sheer mass of the solar system. The devastation doesn't stop at the oceans. This model illustrates how the moon's gravity anchors Earth at a steady 23.5-degree tilt, allowing for predictable seasons. Once that anchor line snaps, Earth loses its balance, wobbling on its axis as it spins. The geographic consequences are immediate. Here you can see the Arctic sea ice melting under blinding sunlight as heat strikes the polar regions. On the opposite end of the globe, stable regions face extreme temperature inversions. Massive glaciers in Antarctica, like the ones shown here, crack and plunge into the ocean as the temperatures that kept them frozen are upended. Below the surface, the physical shaking of the wobbling planet grinds tectonic plates together, awakening dormant volcanoes and pushing deep magma up to the crust. The moon's gravity dictates the physical climate and the structural integrity of the ground we walk on. In this abstract view of Earth's spin, you can see how the moon's orbit applies a heavy slowing force, acting as a brake via rotational friction. Without that braking force, friction drops to zero. Over just 6 days, the Earth's spin rapidly accelerates. The math of this acceleration is stark. A standard 24-hour Earth day shrinks down to a 6-hour cycle of light and dark. This hyper-rotation, paired with weather chaos, makes traditional agriculture impossible. Human survivors would be forced to grow their food artificially, retreating to underground bunkers, relying on UV lights and hydroponics, as seen here. Even our measurement of time collapses. At this rotational speed, a 30-day month flashes by in the equivalent of just 7 old Earth days. The standard units of time we use to organize our lives, from the 24-hour workday to the 365-day year, exist only because of the moon's gravitational drag. We don't have to guess what this looks like long-term. This image shows the barren, desolate surface of Mars, a planet that currently suffers from erratic wobbles and a dead climate. Astrophysical theories suggest that Mars wasn't always like this. Early in its history, it likely hosted a large moon and habitable surface conditions. One theory suggests a dying star fired a beam of gamma radiation that struck and obliterated that Martian moon, leaving the red planet permanently destabilized. Fortunately, our own planet is safe from that kind of explosive stellar threat. Looking at this map of the local galaxy, our nearest stellar neighbor is Alpha Centauri. It is a stable star system located safely over 4 light-years away, posing no risk to our moon. Our lunar neighbor is an active guardian. Looking up at the night sky shouldn't fill us with fear, but with gratitude for the perfectly balanced partnership that keeps us alive.